All right, today we're diving into something that is, frankly, one of the biggest headaches in AI right now. We're talking about that huge, critical gap between an AI sounding like it knows what it's doing and an AI actually being right. You know the feeling, right? You ask an AI something really complex, and this is what you get back. A response that just oozes confidence right before it turns out to be completely wrong. This one little sentence, it perfectly captures one of the toughest challenges in AI today. Now, in the industry, they've got a name for this, a hallucination. It's when an AI just makes stuff up but says it with such conviction that you're tempted to believe it. It's the villain of our story today, and believe me, it can be a really costly one. So let's really dig into this first idea, the confidently wrong AI. And look, this isn't just about an AI getting a simple math problem wrong. No, this is about something way more dangerous. An AI that doesn't just not know something, it doesn't even know that it doesn't know. And yet, it presents its flawed answers like they're gospel. You know, that smooth, totally human-like response is what makes this so incredibly tricky. If you're just messing around with an AI, it's an annoyance. But when you start talking about business or finance or any mission-critical application, a confident but wrong answer isn't a glitch. It's a massive, massive risk. And this is exactly where a new project from a company called Codatta comes into play. They've put out this incredible new data set. But what's so interesting is that it's not designed to show off how smart AI is. It's the total opposite. It's designed to meticulously document exactly where, why, and how these systems break down. Which brings us to a really crucial point here. Fluency isn't truth. I mean, think about it. We are basically wired as humans to trust a confident, well-spoken answer. But with AI, we have to kind of unlearn that instinct. We have to separate how smooth it sounds from its actual grasp on reality. And this slide just lays it all out bare. On one side, you've got fluency. It sounds smart, it's persuasive, it talks just like a person. But on the other side, you have what actually matters, truth. And truth isn't just persuasive, it's precise, it's reliable, and most importantly, it's verifiable. The two are absolutely not the same thing. And this really hammers home the central argument. An AI that can tell you, hey, I don't know the answer to that is actually useful. But an AI that confidently gives you the wrong answer, that is actively dangerous. It leads to terrible decisions and ultimately completely breaks our trust in the technology. And look, this isn't just some theoretical problem. This gap becomes a full-blown crisis in really high-stakes fields. I mean, think about the global financial system, especially in decentralized finance or DeFi. Or what about autonomous agents that are managing trading portfolios? Or even AI tools from companies like Aoki, which help people with disabilities navigate the real world. In these areas, there is literally zero room for error. This quote just says it all, doesn't it? The entire future of AI-driven economies, especially in that fast-growing DeFi space, it all hinges on absolute precision. Pretty sure simply doesn't cut it when there are potentially trillions of dollars on the line. Okay, so if that's the problem, what on earth is the solution? Well, this brings us to section 3, mapping the failures. And it's this really fascinating, kind of counterintuitive approach to building AI we can actually rely on. The idea here is simple, but it's incredibly powerful. The only way to build truly reliable AI is to first understand in painstaking detail every single way it can fail. Instead of just chasing success, we need to become experts in its shortcomings. And Codatta's work here is incredibly thorough. They didn't just poke at one model in a lab. No, they went after the biggest names in the game. We're talking GPT from OpenAI, Gemini from Google, and even major models from giants like Alibaba and ByteDance. This gives our findings some serious weight. So, what's the magic here? What does this dataset actually give us? Well, it pinpoints the exact logical step where an AI goes off the rails, where its reasoning hits a dead end, but its confident tone just keeps right on going. It's like having an error log for an AI's thought process. And developers can use that to teach the models to avoid those same logical traps in the future. This intense focus on failure leads us to our next big idea. Data is the new gold. You know, in the big AI arms race, everyone's just chasing better performance scores. But this work suggests the real treasure, the real value, isn't in the successes, but in the meticulously documented failures. It's a whole new kind of digital asset. Yeah, we've all heard the phrase high-quality data is the new gold. But what's so wild here is that data detailing failure might just be the purest 24-karat version of that gold. mostly because it's so rare and so incredibly instructive. So, by documenting all these failure cases, Codatta isn't just pointing out problems. No, they're handing developers a map, a detailed guide to all the logical pitfalls and contextual blind spots these AIs have. And with that map, they can build better guardrails or even retrain the AI to recognize the patterns of its own mistakes. And maybe, just maybe, respond with a little caution instead of all that false confidence. Which, of course, brings us to the future. Because this isn't just some academic exercise. This is about unlocking the entire next stage of the AI revolution. Seriously, solving this reliability gap isn't just a technical fix. It represents the next trillion-dollar leap in AI's value. The moment AI becomes verifiably reliable is the moment it can finally be woven into the very core of our global economic and social systems. That's the game changer. So the path forward seems pretty clear. First, developers need to get in there and really explore these failure cases to figure out the root causes. Second, they have to use that knowledge to train AIs to understand their own limits, to basically teach them a kind of intellectual humility. And only then can we start building the truly trustworthy tools that the future is going to demand. And the best part is, this isn't just a concept, it's a call to action. The LLM Failure Cases dataset from Codatta is available right now for anyone to go explore on Hugging Face. It's basically an open invitation to join the front lines of building better, safer AI. So let's end with this thought. Maybe the true path to unlocking AI's incredible potential doesn't lie in just celebrating its wins, but in obsessively, meticulously studying its mistakes. Is the map to AI's future really written in the ink of its failures? Based on all this, the answer seems to be a pretty resounding yes.